Good afternoon to everyone. My name is Ashish Kumar Singh. I am working here as assistant professor in EC department. Today I'm going to present a topic that is steady state analysis of series RLC circuit. So when we are analyzing series RLC circuit and want to know what is its behavior when we connect a single phase AC supply single phase AC supply to series RLC circuit, how it behave, how much current it will draw from main supply, and what is the phase relation between voltage and current, and what amount of power actually consumed. Before going to discuss series RLC circuit, we have to first understand how each individual element behave when we connect it to single phase AC supply. As we know that mainly in linear circuit, there are three elements: resistor, inductor, and capacitor. By combination of these three elements, different loads are created. So first, we have to understand how these independent element behaves when they connected to single phase AC supply. So first, we are talking about pure resistance. Its other name is non-inductive resistance. When we connect a non-inductive resistance R to single phase AC supply, let us see. Yeah. When we connect a non-inductive resistance R with a single phase AC supply, that is represented by V equals to Vm sine omega t, as we know that single phase AC supply is generally generated in sinusoidal waveform. So it will be represented by V equals to Vm sine omega t. When this switch is closed, at that instant, this non-inductive resistance draw an instantaneous current I, whose value depends on the instantaneous voltage V. And according to Ohm's law, as we know that Ohm's law states that when a potential difference applied across the end of conductor, a current starts flowing through it, and the current flowing across it is directly proportional to current the potential difference applied. So according to Ohm's law, the relation between instantaneous and voltage is V equals to I into R, where the instantaneous voltage V is given by expression Vm sine omega t. Vm is your maximum value of voltage that is attained by an AC waveform. From this relation, we find the value of instantaneous current, that is small v upon R, and we put the value of instantaneous voltage, that is Vm sine omega t upon R. And as we know that the voltage is maximum, the current flowing through resistance is also maximum. So we can say that Vm upon R is written as maximum current flowing at that time in the circuit. So then by putting Vm upon R equals to Im, because at that time when current is directly proportional to voltage, so when voltage reaches to its maximum value, its current, instantaneous current also will become maximum. From putting the value of Vm upon R equals to Im, we get instantaneous value of current equals to I equals to Im sine omega t. When we apply voltage across non-inductive resistance, the current flowing through the non-inductive resistance is given by formula I equals to Im sine omega t. After getting the value of current, we have to find out what is the phase angle between current and voltage. When we are talking about phase angle is represented by phi, and we define phase angle. It is the angle between applied voltage and current flowing through the circuit. The phi is defined as angle between supply voltage V and I, and it is always measured from current to voltage. Why it is measured from current to voltage? Because result is I, so result is directly proportional to response. So for measuring angle, we have to always measure phase angle from I to V. So for finding the relation between voltage and current, what is the phase angle between V and I, we have to draw a phasor diagram. For phasor diagram, we require two terms, magnitude as well as angle. As we know that the voltage applied across the end of the conduct across the non-inductive resistance is Vm sine omega t. When we are talking about angle, we calculate angle by putting a small t equals to 0. We can easily calculate what is the angle subtended by particular voltage or particular waveform. From here, we say that we seen here the magnitude of voltage, maximum value of voltage is Vm, and the angle, initial angle is when we are putting a small t equals to 0, it will become 0 degree, and the current expression of current equals to Im sine omega t the magnitude of current is Im, and angle is again 0. By plotting the phasor diagram, this is the x-axis and y-axis, and we always measure an angle from real axis, or we can say that x-axis. Here, as we've seen here, from here, the angle subtended by voltage is 0. So voltage is lying along x-axis V, and this angle is 0. And current, I am taking for current red, it is I, and its magnitude is always lesser than voltage, because we get the value of current by dividing voltage by resistance. So as we seen in phasor diagram, voltage and current are in same phase. There will be no phase difference between V and I. They are superimposed on each other. So phase angle between voltage and current is 0 degree. So first we calculate what amount of current flowing through the load. Second, we have to calculate the phase angle So we studied till till yet. The voltage applied across the pure resistive element is Vm sin omega t, and we get the current, that is Im sin omega t, and the phase angle phi, that is angle between voltage and current, is equals to 0. After calculating phase angle, we have to calculate power factor. Power factor is defined as cosine angle between voltage and current. Power factor is defined as cosine angle between voltage and current. And as we seen earlier that the angle between voltage and current is 0, so we can say that power factor, the formula for power factor is cos phi, and as saw that earlier, the phase angle between voltage and current is 0. So by putting the value of phi equals to 0, power factor of purely resistive circuit is 1. The power factor signifies that fraction of power which are available by supply is actually utilized by load to to do some useful work. Here, as seen here, the power factor of the purely resistive circuit is 1. So what amount of power we supplied to the purely resistive circuit, it all converted into useful work. After calculating power factor, we have to find out what amount of power purely resistive element consumed. So as we know, the next is what we have to analyze what amount of power this purely resistive element taken from AC supply. As we know that the formula for power is equals to V into I. So instantaneous power taken by purely resistive circuit is given by instantaneous voltage V into instantaneous current I. As we know that the value of V and I is Vm sin omega t and Im sin omega t. So we put the value of V and I here. This will become Vm sin omega t into Im sin omega t. So instantaneous power taken by purely resistive element is given by Vm Im sin square omega t. This is instantaneous power. And as we know that the frequency of an AC supply is normally either 50 hertz or 60 hertz. So as we know that frequency is the number of cycle completed in 1 second. So in Indian standard, we taken AC frequency of AC supply is 50 hertz. So it complete 50 cycles in 1 second. So it is very difficult to compute instantaneous value. So we calculate here average value of power that will be taken by purely resistive circuit in 1 cycle. For calculating average value, we know that the formula for average value is 1 upon t, integration from 0 to t. T is your time period, that is a time taken by an AC cycle to complete 1 cycle. Ft, that is a function into dt. So for calculating average power, P average that we have to take average value for half cycle. Why we have to calculate average value for half cycle only? Because due to positive and negative symmetry, when we calculate average value for complete cycle, it will become 0. So for calculating average value, we have to calculate average value for only half cycle. So time period for half cycle is your t by 2. Integrate it from 0 to t by 2. Instantaneous value of power is p, with integrate with respect to d omega t. And the time period for sinusoidal waveform, as we know, that 2 pi. So put the value of t and p. This is the value of p. We get average value 1 upon pi 0 to pi, and the instantaneous value of power is Vm Im sine square omega t into d omega t. And as we know that there will be no integration of sine square function, so we have to convert sine square omega t in cos 2 omega t. And as we know that the formula for sine square omega t is 1 minus cos 2 omega t by 2. So we have to just put the value of 1 minus cos 2 omega t by 2 instead of sine square omega t, because we didn't have any integration of sine square omega t. This is 1 upon pi 0 to pi Vm Im. I have taken common 2 here. 1 minus cos 2 omega t into d omega t. So I am taking constant outside of integration Vm Im upon 2 pi integration of 1 with respect to d omega t is your omega t, and integration of cos 2 omega t is sine 2 omega t by 2, and the limit is 0 to pi. After putting the value, we get average value is Vm Im upon 2 pi into pi. Here pi is cancelled out from pi, and we get, I am taking here its value, average power equals to Vm Im by 2. And when we are talking about AC value, we only talking about RMS value. We have to take RMS value in AC quantity, and in DC quantity we are taking maximum value. So we convert it, we can write it as a Vm by root 2 into Im by root 2, and it will become Vrms into IRMS. This is the average power consumed by purely resistive circuit. I have written it here with another color. So that the average power consumed by purely resistive element is Vrms into IRMS. So what we Seen here, when we connect a single non-inductive resistance to single phase AC supply, the current drawn by the voltage, current drawn by the non-inductive resistance is I equals to Im sin omega t, and this current is in same phase with voltage. There will be no phase difference between voltage and current, and power factor of non-inductive resistance is unity, and the power consumed by non-inductive resistance is V into I, where V and I are RMS value, because in AC supply V only takes RMS value. So this is the steady state analysis of purely resistive element, and we will discuss rest elements in another class, that is the what amount of current drawn by purely inductive circuit, what is its phase angle, how what is its power factor, and how much power it is consumed from single phase AC supply.